Have you ever just stopped, looked at a modern manufacturing plant, and wondered, are robots and humans actually going to work side by side in the factories of the future? Or, are these machines just destined to operate in total isolation? It's a massive question, and today, we're going to find the answer. Welcome to This Explainer. Okay, let's dive right in. We're taking an anatomical journey through the totally fascinating and sometimes complex world of industrial robotics. My goal today is to take these highly advanced systems and break them down into simple, really digestible concepts. So here's our roadmap for today. We're going to cover Intro to Robots, Components and Operation, Types of Industrial Robots, where and why we use them, future and careers, and finally, DEVI automation solutions. Let's get started. All right, kicking things off with Section 1, Intro to Robots, where we look at reality versus science fiction. Movies and pop culture totally train us to think of robots as pure science fiction, right? Like these humanoid machines walking around with general intelligence. But in reality, an industrial robot is a highly precise, heavily engineered machine built specifically for manufacturing. They don't really look like us at all. They're designed to do heavy, repetitive tasks with literally zero fatigue and incredible mathematical precision. And this shift definitely didn't happen overnight. The concept first kicked off back in the 1950s. By the 1960s, the automotive industry was deploying the very first industrial robots. Fast forward to the 1980s, and we see the rise of modern robotics. But today, we're literally in the era of AI and smart factory integration. These machines are practically thinking for themselves on the factory floor. Which brings us to Section 2, Components and Operation. We're going to dissect the robot into two main parts, the body and the brain. Think of a robot's physical anatomy like a high school biology lesson, but, for machinery. It actually mirrors human anatomy in a ton of ways. The robot base is kind of like the feet, giving it stability. The robot arm is the skeleton, bending at various joints and axes. Right at the tip, you've got the end effector, or gripper, which acts exactly like a human hand. But what actually moves that skeleton? Well, servo motors are the muscles, giving it power. And finally, sensors and vision cameras act as the five senses, letting the machine feel resistance and physically see the parts it's working on. But hey, muscles are totally useless without a brain, right? On the digital side, this operates a lot like a corporate hierarchy. The robot controller is the immediate brain directing the arm's movement. But it reports to the PLC, which is the logical decision maker for that specific area. We humans actually talk to this whole system using the HMI, which is essentially just a dashboard monitor. Meanwhile, SCADA is like the general manager, sitting in an office overseeing data for the entire plant. And those safety sensors, they're the instant reflexes that shut everything down the second something goes wrong to prevent accidents. So put it all together, and how does it actually flow? First, human programming sets the rules. Next, the controller fires off electrical signals telling the servo motors to move. As the arm is moving, sensors feed data back in real time so it can make these tiny micro-adjustments. Finally, the end effector flawlessly completes the task, whether that's welding a car door or placing a tiny computer chip. It is just this continuous, brilliant loop. All right, moving on to Section 3, Types of Industrial Robots, a diverse species. Just like animals in the wild, robots have evolved into all these different species to survive in different environments. Think of them like different tools in a toolbox. You have articulated robots, which look a lot like human arms and are amazing for welding. SCADA and Cartesian robots move in straight, rigid lines, perfect for crazy fast electronics assembly. Delta robots? They look like these mechanical spiders dropping down from the ceiling, moving with blinding speed to sort items. And then you have cylindrical and polar robots for really specialized reach. They're all born with unique physical traits for very specific jobs. And this actually brings us right back to our opening hook. Will robots work alongside humans? The answer is absolutely yes, thanks to the cobot. Collaborative robots are specifically engineered with advanced force sensors and rounded joints. So unlike traditional, heavy industrial robots that have to be locked away behind big steel safety cages, cobots are designed so that if they bump into you, they just stop safely. They are built to work directly alongside a human operator. Let's get into Section 4, Where and Why We Use Them, the Habitat. Honestly, almost everything you touch on a daily basis probably involved an industrial robot at some point. They weld the chassis in automobile plants, they do hyper-precision pick and place in electronics, they handle material in the food, beverage, and pharmaceutical industries to ensure everything stays perfectly sanitary, from painting and packaging to loading CNC machines and running massive warehouse automation. Their footprint is literally everywhere. Now, it's not just some magic fix-all. I mean, the advantages are absolutely staggering. You get 24/7 operation, consistently high production quality, way better human safety since the robots take on the dangerous jobs, and lower long-term costs. But the challenges are very real. The initial cost to buy and install these systems is incredibly high. And frankly, they are completely useless without highly skilled humans who have the exact programming expertise needed to set them up. Which actually leads us perfectly into Section 5, Future and Careers, the next frontier. Manufacturing is, well, it's constantly leveling up. We started out with just basic, kind of blind automation. Then we gave these machines eyes and brains by integrating machine vision and AI. Now we're using the Industrial Internet of Things, or IIoT, to connect everything to the cloud. And that leads us straight into Industry 4.0, the smart factory, where machines talk to each other, predict when they need maintenance, and optimize production in real time. And because things are evolving so incredibly fast, career opportunities are just exploding right now. If you're a student, an ITI or diploma holder, or an engineering professional, this is the field to be in. The industry desperately needs PLC programmers, robotics and automation engineers, and highly skilled maintenance technicians and electricians. So no, the robots aren't taking all the jobs, they're actually creating these incredibly highly skilled, high-paying new ones. And that takes us to our final stop, Section 6, DEVI Automation Solutions, your automation partner. A prime example of an organization actively building this future right now is DEVI Automation Solutions. They offer comprehensive services across that entire spectrum we just talked about. Whether you're looking at core industrial automation, PLC programming, HMI development, and SCADA systems, or if you're jumping into cutting-edge implementations with AI and IIoT. They're even taking these exact same principles and applying them to smart agriculture, home automation, and solar solutions. They are practically engineering a better tomorrow across multiple sectors. So, if you found this explainer helpful in wrapping your head around the complex world of robotics, definitely engage with us. Like, share, and comment down below with what automation or robotics topic you'd love to see explained next. For more of these technical deep dives, make sure to hit subscribe and ring that bell on the DEVI Automation Solutions YouTube channel. Oh, and if your facility is ready to take the leap into automation, you can reach out to them directly at deviautomationsolutions@gmail.com. I want to leave you with this one final thought. We've seen how robots evolved from these mindless mechanical arms into really smart, collaborative cobots. As they keep gaining the ability to truly see and think using AI, what currently impossible task do you think they're going to conquer next in your specific industry? Think about it. Thanks so much for learning with me today, and I'll catch you in the next explainer.